Hi there then, so today's lesson 14.1 is capture and recapture. So our objectives for today then to be able to use the capture, mark and recapture method for estimating population size. So what do we mean by that? Well, capture and recapture is about estimating the population of things that we couldn't normally count. If we wanted to know how many fish there are in a lake, we certainly can't catch every single fish and count them. The same with the deer in the park, horses, sweets, etc. So a few examples there of where we might want to know how many of something there is, but we can't actually physically catch them. Okay, it's a familiar problem for ecologists then, and we can see it was devised by a Danish marine biologist back in 1896. So they've been doing this for quite a long time. So when you see things like how many tigers there are left in the wild, it's not that they've actually caught every single tiger and counted them, it's that they will have marked a selection of tigers and used a similar process to this to estimate how many there are still out there. Now I've included a little link below for Johnny Ball and the Black Taxi video, so another YouTube video that you can go and watch, so it might be worth pausing this video now and having a little watch of that first, or if not, having a watch of that at the end. It's quite a good way of seeing this process in action. Okay, so the method then, the steps we need to go through. We need to take a sample of the population, so we capture a group from that population. We're going to mark each item. We're then going to put them back into the population and make sure they're thoroughly mixed up. That's really important that they've mixed back in with their original population. We're then going to take a second sample and count how many are marked. So that's our recapture. And we're going to assume that the proportion, the fraction of the ones marked in the new sample is the same as the proportion of the marked ones from our first population. Now, having said that, then we're making some assumptions as we go. So, important assumptions that we've made using this method. We've assumed that none of the population has left, so nobody has left the group. We're assuming there are no new arrivals. We're also assuming there are no births or deaths. So the group size is essentially the same as it was at the beginning. And we've assumed that none of the tags or markings that we've used have been lost, so they've not fallen off or washed off in any way. Pause the video now, make a note of the method and those assumptions. Quite often in the exam questions you will be asked to write down one or two of the assumptions you've used when using this process. It's important that we know what those are. Okay, let's have a look at an example then. So 10 fish are caught in a lake, marked and released back into the lake. A week later, 20 fish are caught and 4 are found to be marked. Estimate the number of fish in the lake. So we need to use fractions to do this. We're looking at proportion. So originally then, we had 10 fish out of an unknown population. So I've just called the unknown population N. So we've got 10 fish that we've marked and then released. We've then caught 20 fish, so we know the population that we've caught, and 4 of them are marked. Now we're assuming that these fractions are equivalent, so we need to make them equivalent. Now there are different ways of doing this. The way I would normally do it is to rearrange the equation. So if I want to get rid of divisions, dividing by n, dividing by 20, then we're going to multiply both sides by n and both sides by 20. So we end up with 10 times 20 and 4 times n. We want to find out n, so to get rid of a times by 4, we're going to divide by 4. So 10 times 20 divided by 4 means n is 50. So there are approximately 50 fish in the lake. So with those assumptions that we're assuming that the population is the same fraction as the marked fish. Okay, let's have a look at another example then. So Cameron wants to know how many snails are in his garden. He collects 5 of them and marks them and puts them back in the garden. A few days later he collects 10 snails and finds 2 of them are marked. So we're going to estimate the number of snails. So again, starting with our fractions then. So we started off We collected 5 out of an unknown population and we've marked those. We've released them and we've caught 10 more, so we know our population size, and 2 of those are marked. So again, you can see the marked values are at the top, the populations at the bottom, and we want to assume again that these are going to be equivalent. So let's rearrange this equation then. So multiplying by n and by 10 gives us 5 times 10 equals 2 times n. We want to get n on its own, so we're going to divide both sides by 2. So 5 times 10 divided by 2 gives us 25. So there are approximately 25 snails in the garden. It then tells us we need to state 2 assumptions that we've made in order for the estimate to be accurate. So we need to list 2 of those assumptions that we've looked at earlier. So I've said that no snails left the garden and no more entered, so we've had no emigration or immigration, and that none of the markings on the snails have washed off over those few days. Okay, make sure you're happy with those examples. Make sure you're happy with how we've set out our fractions and how we've rearranged those. So the process is the same every time. Okay, your turn then. Pause the video now, have a go at these questions. Okay, let's have a look at the solutions then. So we're working out an estimate for the number of bees and we've caught 50. So we've caught 50 out of our unknown population, which is equal to our 8 marked ones out of our group of 40 that we've caught. Let's again rearrange our equation. We end up with 50 times 40 divided by 8, so that's 250. So there are approximately 250 bees in the beehive, and we're asked to write down our assumptions. So my assumptions are the size of the colony did not change, so that's no births, no deaths, no one coming, no one going, and the dye didn't wash off of any of the bees. The second one then, we've got our farmer, so we've caught 120 rabbits out of our unknown population, and then we've caught 15 tagged out of 70, so we'll rearrange that equation. We get 120 times 70 divided by 15, which is 560. So there are approximately 560 rabbits. And again, it says there you must write down any assumptions that you've made. So the assumptions that we've made are that the number of rabbits on the farm did not change. So again, no births, deaths, no one coming or going, and that none of the rabbits have lost their tags. So you'll see from all of these questions that the process each time is the same and that the assumptions are the same as well. So making sure you know the process we're working through and those key assumptions, you'll be able to answer all of these questions. Okay, thank you for watching this lesson today then. We'll be moving on to 14.2, which is cumulative frequency.